Okay, so we left off Friday. I think we were bisecting angles on page 219, and we're going to kind of run out of justification why the bisection works. And being I don't have a straight edge and I don't have a compass, and that's what they're doing, is everything's just straight edge and compass, so you don't have markings on the straight edge, you don't have any units on the compass, you can only set it down and get a length. And so we'll kind of lay it out and show why the construction would work. And the construction on page 219, construction 3, bisect an angle. So if you have any angle there, and we'll just list it as angle A. So this is what you would do. I'm going to use the red to show, that we're laying out a compass. So if you lay out a compass at any length and you just put the one point right there, your spear point, and then if you just lay out an arc like that. Now, what essentially you have developed is you have developed these two sides are congruent. Now, if you take any other, you could leave it at that size on your compass, or you could take any other length on the compass. That would be over half of the distance between those, the arc length there. And then you could lay out, put one point here, lay out an arc, put a point here with the same arc length, go here, and then essentially what you've done is you've created those two sides that are congruent. So these two are congruent, and then you would connect A out to the intersection point. So you run this out, and you would have created a bisector the angle, and the proof of that is that if you letter the thing out, if you have this B, C, D, then what you have is you have, first of all, AB is congruent to AD, and this is construction. And then you BC is congruent to DC, and this is construction. And the third thing is then you have AC is congruent to AC, and this is reflection. Then you have the triangle ABC is congruent to triangle ADC by side, 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 and therefore angle BAC is congruent to angle DAC. corresponding parts, and AC bisects. Okay. Angle A and B. B by definition. So that's why the construction works, because of the congruency of triangles. The construction 4 on page 220 says to construct a perpendicular to a point on a line. So you just have a line given to you, and then you get a point on that line, and then you're going to construct a perpendicular to it. So what you do is you put your point side on A at whatever arc you want, and then you strike the arc on those 2 points. You've essentially established then that these two, A to that, maybe I should use a different color here. That these two are congruent. Now, what you have to do is you have to increase the size of your compass, your extension of your compass. And then you strike, you put one point here, strike an arc, and then you put the point here, and you strike an arc, and then what you do is you connect this point with that intersection. It isn't, everything isn't quite right, but that's, you just have to give me that it goes through there, and it will go through there. Now what you've essentially done is you have, through construction, you have constructed this side, and this side is congruent. And if we letter that off, we go B, C, D, then what we've done, we've gotten AB congruent to AD, and that's by construction. And then we have BC congruent to DC, and that's also by construction. Then AC, let's see, AC is going to be congruent to AC reflection. Then you have triangle ABC is congruent to triangle ADC, and that's side, oops, yeah, side, I thought I didn't. And then angle BAC is congruent to angle DAC by corresponding parts of congruent triangles. And then we're trying to prove perpendicular. So then angle BAC, I guess the measure of that angle is equal to the measure of this angle is equal to 90 degrees. That'd be definition of a straight angle. And then therefore AC is perpendicular to the line. AC is perpendicular to line, and BD
definition
by
of
definition.
straight angles?
What'd you say?
Is that a definition of straight angles?
Definition of a straight angle. I mean, you got two angles that are equal. The sum is a straight angle, so you'd have to have each one would have to be 90. It's a pretty loose proof, but it's more show than it is. And they didn't, what they did is I said that this line is perpendicular to the line BD, or that segment is. And it's actually a line, because they didn't say 2 points BD. We established the 2 points BD. So it's just those points are on the line. And technically, if you really came down to it, you'd say the line segment here, AC, perpendicular to the line BD. But nevertheless, that's the construction and justification for that construction.
Are you going to give us construction on page 12?
Say that again. What?
Wednesday? We're going to give us construction on page Wednesday.
There'll be the construction problems will be the problems from the end of this section, and those are the type of construction problems. I will take 1, 3, 5, 7, 9, 11, and so on. Pick those kinds of problems up. And to the extent that those are construction problems, and then the verification of the construction is it's some sort of a justification. And like I say, the justification isn't a rigorous proof, but it has to be consistent proof. Okay, construction 5 says construct a perpendicular to a line from a point not on the line. So we have technically I should draw, it should be a line. It's not, but it should be pointed that it's a line. It isn't a line segment that you have established that you have to do, and then construct it perpendicular to a line from a point not on the line. So then you have this point out here where it's at, not on that line. I think I did this one, didn't I?
You put them for
I did construction 5, didn't I?
No, you just did 4.
Oh, I did 4. Okay. This is construction 5. Okay. So then the way you do this, and this is the point that you want the perpendicular to. So you point it into your compass on A. You make sure your compass is longer than the distance from A to the line. And then you strike an arc that establishes there. And what you've done then is you've made in striking those arcs, you have those two that are congruent. And you want to be perpendicular to that. So what you do now is you can either take that same arc length or another arc length that's longer than halfway between this line and strike the arc again. Put one endpoint here, the pointy point there. Make your arc, put the point here, make an arc, and what you've done is you've created the line from here to here and one from here. Those two line segments now are congruent. And then you join the line from this point out through there. Now that construction is what we've just shown is a bisected angle. That's the way we bisected the angle. So what we have essentially is we have this angle equals this angle because of construction 3. Okay. So now we can prove that this is the perpendicular bisector of that line segment. So I'm ready to set that out. This is going to be B, C, D, E. And what I'm trying to prove is that AC is perpendicular to BD. And if I do that, then I've constructed a perpendicular line to from a point to a line. I've constructed a perpendicular. Well, I've shown that these two are 90 degrees. So in order to show that, the first thing is AB, that line segment is congruent to AD. And that's construction. And then BC is congruent to DC, and that's also construction. 3 angle B A C is congruent to angle D A C, and that's construction 3, right? Bisected angle. Construction Now what I have is I can say then that triangle I'm not ready. I have to say that AC
Right, side.
is, I didn't have to do that angle bisector. I thought I was going to be able to get, I guess this is what I can do. I can say AC is congruent to AC, and that's reflexive property. Now then, triangle B triangle. Oh, I don't want to do therefore. Triangle BCA is congruent to triangle DCA, and that's side angle side. And therefore, I guess, therefore,
Professor, would it be side? What angle are you going to use?
no, I'm using this angle, right? Let's see, I'm better. I'm using this angle and this angle are congruent, and this side is congruent to itself, so I can show that BCA is congruent to DCA, DE, no, not DC. Here's where I confused you. It's DE, because I want to show that DEA is equal to BEA. And I got this side is congruent to itself. I got this side congruent to this side, and this angle are congruent. Therefore, I can say that BEA is congruent to DEA. I didn't have this thing written very good.
Just supposed to be definition of straight.
Yeah. Then what I do is angle BEA is congruent to angle DEA, and that's corresponding parts. And then I can say that I don't know how obvious. I mean, if they're equal, then they're 90-degree angles, right? I'm just gonna say the measure of angle BEA has to equal the measure of angle DEA, which equals 90 degrees, and that's definition of straight angle. And then AE is perpendicular. AE. Maybe what I really should say is EA. The way I'm constructing this thing, I'm actually going AE. That ray is going to be perpendicular to BD, that definition of perpendicular. Okay. Next.
Can I do it?
Oh,
Can I do it?
got it?
Yep.
Okay. Construction 6. To construct the perpendicular bisector of a segment. So what you want to have it perpendicular and you want it to bisect. So we have a segment. So we have endpoints. That's the line segment. So we want to show that the line is a perpendicular bisector. And the way you do it is you would take your compass and you would make it longer than half the distance of AB. And then you swing an arc up here, and then you put your point here and you'd swing an arc up here. So then what you've done, construction, you have this side and that side congruent. So that one and that one. Now, it doesn't look that way, but that's what it's supposed to be. Now you would take, it wouldn't make any difference whether you took that same length or if you took another length. But as long as it is longer than the distance from A to B, and you would swing another arc down here and from A, and then you'd swing an arc this way, and you would have established those two are. That don't even look good. But you would have established that this side and this side are congruent. And then if you join them, I hate to join them because it isn't even going to look like it should. But if you join those 2 points, now what we have to do is we have to show that C, D, and then this is E. And we have to show that not only is AE equal to BE, but also that angle AEC and angle BEC are perpendicular. Because we want a perpendicular bisector of. So, anyone have an idea on it? this is what I would establish, is that you bisect, I think it'd be shorter. You'd essentially say prove through construction 3 that green line is a bisector of the angle up there, and then prove the triangles AEC and BEC are congruent. And then, let's see,
Just like the last proof, side
Yeah.
angle side.
I wonder if there's a shorter way to construct the perpendicular line. So we don't have to repeat ourselves. That's all I'm thinking about with it. I mean, that'd be quicker to do than to make triangle ACD congruent to the other one. So I'm gonna give a shot at trying to talk my way through that. Okay, so how are we gonna say that? We got AC is congruent to BC, and that's construction. And I'm gonna go CE is congruent to CE, and that's by reflection.
The angle, bisected angle.
Yeah, I think I'm just gonna try to say those two angles are equal by construction 3. That angle ACE is congruent to angle DBCE by construction 3. And triangle AEC is congruent to triangle BEC, and that's side angle side. Oh, I should have said, no, I did. I got CE and CE. Side angle side. Now, AE is congruent to BE, corresponding parts, congruent triangles. I guess I'm going to go through that same kind of thing. Angle AEC is congruent to angle BEC, and I'm just going to say equal to 90 degrees at corresponding parts. And then I'm going to say that, not a proof, but it shows that CE is perpendicular bisector AB. They're the same. The perpendicular to a line from a, construct the perpendicular bisector of a segment. So I could say, therefore, CD, that line is perpendicular bisector of line segment AB.
I got a question. Isn't number 4 equals to the same thing as number 6?
Number 4, well, that's a triangle. 4 is a triangle, 6 is an angle. You said, are they the same?
Because they're opposites.
See, 4 is the triangle, and then I'm saying that 6 is because the triangles are congruent, then the angles are congruent,
It's 90 degrees.
and then it's 90 degrees, I guess probably should make a better statement. Definition of a straight angle, I guess. This one we should probably put. If it was a rigorous proof, you'd want to do a lot more than that.
So Professor, we're just doing theory. You're not gonna have us go and get a compass, are you?
Oh, no.
Okay.
No. I think you can, I'm hoping that what you can do is you can visualize it,
Right.
what I'm telling you is, and I'm trying to show you the justification why that kind of construction works by the theory, and that's what they're doing is construction is not just some magical thing that comes out of the air. It has a basis in theory, and that's kind of what I'm trying to show. And when they show it, it's not a rigorous proof, and that's not what I'm trying to do, is do any rigor to the proof. It's pretty much show it now on page 225, number 2. It says draw a line segment AB using your compass and straight edge to construct another line segment. Length is 3 times AB. So another line segment. So this is what they're telling us. They're saying that we have a line segment. I'm going to make that something shorter. I don't know what I'm doing here. A, B. And then this is what we're going to do, is we're going to on that line, we're going to construct a line segment that is 3 times that segment AB. So I think you probably, what you do is you put your point part of your compass on A, swing an arc out on B, then you'd have established yourself some point down here. You put your point part of your segment there, and you have the arc the same length that you had to keep it at AB. Lay it out, and then put the point segment there, lay it out, and put the point segment there, and lay it out. And then you would have constructed C.
No, A to C.
Well, we don't need you to construct this new line segment 3 times as long. And what, I guess, what you would say is that AE, because by construction, what you've done is you've done AB congruent to CE, and that's just construction. And then AB is congruent to EF, and that's construction. And then AB is congruent to FD, and that's construction. And you know, the line segment CD is equal to 3 times the line segment AB. That's essentially what you're doing, right?
Can I get that?
Professor, what are we gonna cover on the quiz?
We'll cover 4.3. Did we do anything? I think 4.3, maybe something on this one, maybe. I'm gonna do 4.
Right, because we did in the last quiz 4-2. Okay, this is gonna be 4-3.
Mm-hmm. 4 says draw an obtuse angle. Use your compass and the straight edge to construct another angle whose measure is twice A. Essentially, segments. So that's an obtuse angle, right? What you would do, put your point of your compass right there, and then swing an arc. That looks like it's increasing arc. Huh. Here. I wonder if I can do it better with this line thing. You just have to give it to me. Now, you put your point right here of your compass and measure that distance right there. So what we're doing is we got a line segment there. Now with that same length on your compass, you put the point here and swing an arc down here. And that don't even look good, but so what we've constructed then, we've constructed this, these two are congruent. And then
That shows you double the angle measure.
you double the angle, but the only thing is you can prove it. You know, if you have A, B, C, D. Now, you just have to give this to me. This distance right here is congruent to that distance, is congruent to that distance. Because I put the compass down and swung it hard. Okay, now then, what I'm trying to do is I'm trying to show, I'm gonna show that this, if this and this are gonna be equal, and I'm gonna do it by, you see the congruent triangles?
Mm-hmm.
You got the triangle DAC that's gonna be congruent to BAC, side, side, side. Then these two angles are gonna be congruent by corresponding parts, and then you double the size of your angle.
And there's your proof.
Yeah.
Interesting.
I'm just out of time, that's why I shortened it up. Okay.
Three.